for me doing a sample project, I think it's also important to start with modules that you have, modules that you understand, and just skills that you already have, and see what you can make with that rather than come up with a project idea and then try to learn and buy everything to make the project. Like that can kind of come later. Generally start with something you know you can probably do and evolve it from there. So for me, first of all, I have this distance sensor, right? That's all I know about it so far. It's pretty cheap. I have a couple of them now. It just senses distance, right? So just looking at it, you can just kind of read it. So when you see a bunch of numbers and letters like this, that's generally going to be the name of the device. So if I Google this right now, it'll come up as a distance sensor and it'll tell me a little bit more information about it, right? So it has 4 pins here and they're all labeled. VCC, that's voltage, so that's just you're giving it power. Ground, this is going to need to go to ground to close the circuit from power to ground. There's a trig and an echo. Trig is for trigger, echo is just echo. I don't need to know what these do yet. I don't want to know what they do yet, but I just know that these pins are also on this module, right? And you have this T and this R. Again, you don't need to know this, but in hindsight, the T is for transmit, the R is for receive. That's also common, so if you see it on a board somewhere, you can kind of help piece it together. So my first Google, how to use this thing, this is what came up, right? I have an Arduino. I know this is the 5 volt, this is the ground, and I can see these wires, and they're going to 5 volt and ground on the distance sensor. So I'm like, all right, this provides some amount of resistance. It needs 5 volts. I can do that very easily. Then you have the green and yellow, which are going to D2 and D3. So I know, all right, whatever is going through these 2 pins, it is then going into a pin here. So I don't know if this device is sending something into the Arduino or whether the Arduino is sending something into the device. But if I do this wiring without even knowing any more about it, I can complete this project, right? And if there was a resistor or something that I need to change the amount of current, it would be in the picture, and so it's not, right? If you read the description here, in order to generate the ultrasound, we need to set the trigger pin on a high state for 10 milliseconds. That will send out an 8-cycle sonic burst, blah, blah, blah. We don't need to know this. If you want, you can go back and learn it, but like a toilet, we don't need to know how it works. We just need to know how to use it, and then we can kind of understand a little bit more, right? So that first tutorial that I went through, the first Google result, it had these comments at the bottom, right? Program seems kind of fragile. That doesn't sound good. I get 16 expecting 17. Not too bad. All right, so it's not awful. You kind of read through these and you see people kind of having a little bit to say about that particular project. So I'm thinking, all right, the way they did it, maybe not the best. So I just Google it again, go to the second result, try it again. This one says you will need the new ping library. You can download it here. I use the sample library sketch and upload it to my Arduino Uno. All right, so it works for this guy, which means it should work for us. Maybe I don't know what a library is. And then here's some sample code that, we're just going to trust that this works. I can literally copy and paste this into the IDE, upload it to my board, copy the wiring that's already been done, and it's going to do something. I don't know exactly what that is yet. If I wanted to know that or how the code worked, I could, but that's not the priority here, right? We're just here to scout for information. So, just want to touch on a library is a collection of code that's already been written for a specific purpose by someone else that you usually just want to download to help with your own projects. So for example, this new ping library is code that has already been written by someone else to help out specifically with this device. So we'll go through this code and kind of analyze it later, but you can see there's a line here about new ping that's from this library. And of course, if you've worked with a programming language before, you should know include new ping is including this library. So here's another device, similar idea. This is how you wire it. Cool. You don't need to know too much more than that. You have this yellow pin going in. This is what the motor looks like. This is what happens when you buy a servo motor. This is what you get. It has 3 different wires and comes with example code. You see the include again, which means, all right, there's a library that comes with this that is going to make my life a lot easier. I don't even really need to know that much about the code or what's going on. I can use this. So, pro tip, find things you can do first, then make the project. We've kind of touched on that. And then you do need to learn certain things. Like obviously, you can't really make out what's going on here, but if you just kind of Google how to wire to a servo motor. There'll be something that pops up. It'll teach you. Red goes to ground. Brown goes to ground, red goes to power, and orange is the data line. That's the one that's going into an input-output pin. Not too complicated. We don't need to get into the specifics yet. So talks more about the servo library. This actually explains it. So this is helpful for, all right, now I have copied this example code here, and I've put it in my IDE, and I've done the wiring, and it works. But now I actually am going to start diving into what the code means. So these are the functions in the servo library. So this code, when you're writing it, it already assumes that you have included the servo at the top, right? Servo X. X is the name that you'll use when calling the servo to do something. Okay, so I just now know for each of my servo motors I'm using, I need to create a servo and give it a name. So right here they call it my servo. Cool, and it even says, create servo object to control a servo. Perfect. This all makes sense. We're taking it one step at a time. This stuff is so well documented that it makes very easy to understand, and it's also why you should document code that you write, so that when you go back in 3 months and try to read it, it doesn't look like a language you've never seen before. All right, next line, x.attach y. All right, x is the name that you'll be using when calling the servo. We've already seen that earlier. Cool. Y, the pin to attach the servo. All right, what do we have here? My servo.attach 9. So my servo has already been set up, and then we're calling this method. Hopefully you're familiar with that already. On pin 9. Attaches the servo on pin 9. Cool. We don't know exactly what that means to attach it yet, but if you're clever, you'll kind of catch on that obviously the power pins aren't doing a whole lot of logic. So this is what's actually sending information to the servo motor to control it. This isn't in the library, but obviously they just have an int here for position. So it's easier to help with that later. I know I'm not just skipping that over, but it's also not explicitly part of the library. This is obviously just a regular integer. X.write pause. So X, again, the same servo, cool. Pause is the angle that you want your servo motor to go to. It has to be something between 0 and 180. All right, so now I feel like I can kind of control the Arduino. Here's a line that, well, we know what a for loop does, hopefully. So it's going through every number from 0 to 180, and it's moving it to that position, right? The delay is also important here, and this is something that you'll see in the code, and that also makes sense intuitively. And if you didn't know this, you could try code without it, then realize, wow, this isn't going too well, and come back to this. But you essentially need a small delay, and if you look up delay, this is, I believe, the number of milliseconds, so like 15 milliseconds. You need to give it a little time to move before you just write another position, because the arm of the servo motor here can't like physically move instantly. So you got to give it a little break. Obviously, if you didn't know that, you'd figure it out pretty quickly when it would be struggling to keep up with your instruction, right? And then goes from 180 back down to 0. So this is just going to move the arm 180 degrees and then slowly bring it back, and just do that over and over and over because it's in this loop. So pretty simple program. And then I'm sure you can already think of ways that you could have the position change based on certain other things, right? So maybe I wanted it to take larger steps. So instead of just incrementing by 1, it would be larger steps, or it would be based on some other variable, right? As long as the number is between 0 and 180, the servo will move. And then you just got to give it a small delay. So now, from a code perspective, I kind of understand how the servo works. And then also, to get the library, you just go into the library manager, type in servo, and then boom, built in by Arduino, installed, all this helpful stuff. There's usually going to be an install button. Obviously, it's already installed here, so you can't install it again. But it'll be very easy to get your hands on the library. Obviously, they want to give you the tools that you need. And so if you're familiar with programming, hopefully up to here, this has made perfect sense. And if it doesn't, again, plenty of resources online, or you can just go back and rewatch the parts you don't understand. So how to get some of this stuff, right? Because I've never seen a servo motor in a store before. Adafruit is a website that I personally really like. They have a lot of different stuff, and they also have all these awesome tidbits on the website. They have a bunch of pictures of it, ton of technical details. If that's particularly relevant, you don't need to know this stuff. Like, you don't need to know the working temperature in Celsius generally, I don't think, people are generally in negative 30 or 60 degrees Celsius conditions. That's a bit much. It's a description. They're usually kind of humorous, which I also enjoy. They have an awesome intro video. This is your bread and butter. This is going to be way helpful than I am going to be, right? So when you go on and you're shopping for something, watch these intro videos. It'll teach you how to use it. It'll show you a cool function of it, and maybe it'll inspire you to make a project, right? And they have similar projects. So if maybe you didn't want this specific servo, like this one only goes 180 degrees. Some of these, I'm sure, are 360 degrees. They go all the way around, which is way cooler, right? So depending on your project, maybe you're going to need something else. So I love Adafruit. Always blows me away how much they have. And you can use a lot of other websites. Obviously, I showed earlier with eBay, or you can just Google it. The one thing I would say, there's a lot of stuff that's made in China that is going to be way cheaper, but they skimp on certain precautions that other boards may take. I know especially if you buy a cheaper Arduino that's not officially licensed, there's sometimes you got to play around with certain settings in the IDE to be able to properly upload code. That's been a big headache for me in the past. I just read, again, comments on some of these products that you're buying, and it also can take a really long time to ship because obviously China's a far way away. So order the stuff knowing that it's not going to come the next day. And if you have a project that's urgent, it's probably not going to help you that much. So now we're going to get into showing off how I physically make this project and some of the code.